Hello student, today our topic is inverse function. So for being inverse function, we should be very much clear in these five things. What are these five things? First thing is we should be very much clear about relation and function. This difference should be very much clear. Okay. Second thing, reciprocal of a function and inverse of a function. This difference should be very much clear. Okay. Then the third thing is one oneness of a function, and the D is ontoness of a function, and the fifth thing is invertible. Invertible, whether the function is invertible or not. So the one-oneness, that is n a less than equal to n b, and n a greater than equal to n b, and if invertible, that implies NA is equal to NB. So you understand these two things applying simultaneously, C and D. And here the function means F A to B. We are talking like this. Okay, so we'll discuss one by one. So first of all, we check whether you know the reciprocal function or not. Relation and function. Okay, so we take A. A is equal to 1 and 2, and B we take 3, 4, 5, and C we take 6 and 7. If the relation R1 1 3 1 4 and 2 5, so R1 from A to B, okay, and then R2 is from A to C. It is defined like 1 to 6 and 2 to 7. So you know very well that R1 is a function. No, and R2 is a function. Why? Why the R1 is not a function? Because you know this one element having two images, right? One element has two images. So in the definition, you know, one element has only one image. So this is not a function, R2 is a function. So now you know the difference between relation and function. So now we come to the second part. What is that? The second part is reciprocal and inverse. So if you have been given f1 is equal to 2, so reciprocal of f1 will be equal to 1 by f1 is equal to 1 by 2, but inverse will be f inverse 2 is equal to 1. This is like this. We will understand why is it happening so, but you have studied already little bit in 11th class. Like you know, you have studied tan pi by 4 is equal to 1 implies tan inverse 1 is equal to pi by 4. Little bit. If you know, that's good. If you don't know that much, it is also good. Hmm? And the reciprocal of tan pi by 4 is 1 upon tan pi by 4. So this is reciprocal. That you know very well. Okay. So this is the reciprocal and the inverse are not same thing in calculus. Okay. That much if you know it's sufficient. Okay, now this is the second thing. Now there are two terms. First of all, discussion of inverse function. First of all, the one-oneness or one-one function. Okay, if the function is one-one, then what is the criteria? So each element, if the function is from A to B, then each element has distinct image, exclusive image, no? Distinct image, exclusive image in the set B. Like why? Why is it so? That is the question. Why? For being invertible function, this is the criteria. So if you first of all, what is one function. That if I show you this 1 2 and 6 7, so if I show like this, so this is like why we'll discuss later. Okay, first of all, we should know the definition of one function. So this is not 1 1. Okay, this is a many one function. If a function is not 1 1, it will be called many one. Okay, and if I show like this, like A to B and C and D, and this is connected with this is connected with this, so this is a 1 1 function. Okay, and if I show you like 1 2 3 and here 4 5 6 7, so this 1 and this 6 and this 7, so this is also 1 1 function. Okay, so like if the function is from set A to B, so you know that NA less than equal to NB for the existence of 1 1 function, for the existence of 1 1 function. Is that clear? Okay, fine, good, good. Okay, otherwise 1 1 function will not exist if NA greater than NB. That you understood? Like if I show you like 1 2 and if here only one element 3, so here this will not, this is shows like, is it clear? This is a function but cannot be 1 1 because it cannot be 1 1 because n a greater than n b. Fine. So like now you understood very well. Okay, so now we discuss about onto function. So what is onto function first of all? Okay, and how it is connected with the inverse function. So these are two different things. Okay, so onto function means like this 1 2 3 and this is a 4 5. Huh. So if I connect them like, and you can say 6 7, so like this this, so this is 1 1. Okay, this is 1 1 function, right? But it's not onto. Why? Because this is, suppose this is from C to D function. So this time from the set D, from the set D, each element has at least one pre-image in the set C. Okay, so here we are talking about pre-image, not image. Be very much clear. No. So, and one pre-image in the set C. Hmm? And so for function A to B and A and greater than equal to NB for the existence of onto function, for the existence of onto function. Why is it so? So we will see. See here and a, like you can see this is the example one. So in the example one, you can see clearly and c is less than and d. So it cannot be one onto function. It cannot be onto. But if I take the example two, like something like this, like 1 2, and here I take c only, so this will be, of course, this is onto function. Okay, this is a to b. No, so this is onto function. And if I say like 1 2 3 and e f g and this is also onto function. Understood? So for onto function, this is the criteria, right? So like that. In other word, if codomain is equal to range, that implies onto function. So this is the shortcut to memorize this. Okay. So this is the onto function, and now we discuss about the part E. What is the part E? That function is invertible or not? Invertible function. So for being invertible function, C and D simultaneously. But why? Or in other word, NA is equal to NB, right? But vice versa may not be true. But vice versa may not be true. So if the function is invertible, then n is equal to nb. But if n is equal to nb, it's not necessary that function is invertible. Fine. So the first point is why. So for that, the first question is, what is inverse function? What is inverse function? If you know what is inverse function, then only you can understand these two criterias. Okay, C and D. So if you know that function a to b, suppose set A has 1 2, and this is E F, and this is set A to B, like this. So this is the mapping. So reverse of mapping will give you inverse function. So what is the reverse of mapping? So reverse of mapping is like this is E, this is F, and this is 1, this is 2, this arrow part. Okay, just focus on this arrow and here. So this is basically this is B and this is A and this is like this. Okay, so we will say F inverse from B to A. This is like reverse of mapping. Okay, so if neither function is 1 1 not onto, neither 1 1 nor onto, so what will be the case? Like A, B and C and D. And if this is the condition, so this function is not neither 1 1 nor onto, right? So is this invertible? Is the reverse of mapping exist? Will it just make reverse of mapping will make the function exist? No. Like if you make this function like that, reverse of mapping, just what will happen? It will go like this and it will go like this, a to b. So is this a function? This is not a function. This is not a function. So this is not an invertible function. So what does this imply? This imply f a to b is not invertible. Okay. Now only one, not on two. So what will happen in that case? Like A, B, C, and then 1, 2, 3, 4. So this is a 1 1 function. But this is on to no. So if you just do the reverse of this, reverse mapping, what will happen? This 1, 2, 3, 4, and this A, B, C. So this will be like this. Is this a function? No. This is not a function. And this is a function from A to B. Okay. So if the function is only one, not all two, the reverse of mapping will not create a function. Okay. In the same way, just make not 1 1 but on 2. So what will happen? So here A, B, and 1. So if you connect this like this, so this is on 2 but not 1 1. Understood? So will this create invertible? No. It's like reverse. What will it create? This one, this A, this B. Is it a function? No. This is also not a function. Okay. So now we come to the last one. 1 1 and on to. 1 1 and on to both. So for 1 1, n A less than equal to n B. And for on to n A greater than n B. So both means n A is equal to n B. Understood? So if you make like this, it's a very simple thing. It's not so difficult. That 1, 2, and then C and D. So this is now 1 1 as well as on 2, right? So if you make a reverse of that, so this is 1, this is 2, and this is C, this is D. Okay, now this is function. Yes, this is the function also. And this inverse function exists. This function A to B and this inverse function B to A. So both exist, right? So only if the function is 1 1 and on 2, then only its inverse function exists. So this is the purpose of video, that you should be very much familiar with the 1 1 and onto function, and what are the concept of inverse function, and why the function should be 1 1 and onto for being invertible. So we will say that f a to b is invertible and f inverse is inverse of f, and we can say f is inverse of f inverse and f inverse is inverse of f. Both are inverse of each other. Okay, fine. Thank you.